With the development of human civilization and advancement in engineering and technology during the 20th century, the ingenuity of man has enabled the creation of modern buildings which are aesthetically more beautiful, functionally more satisfactory, structurally safe and strong. Buildings are built up not only for residential purposes but also for business, educational, assembly purposes, etc. A modern building is therefore constructed not only to provide protection but also have adequate accommodation, aesthetically pleasing appearance, and functional comforts and ease. The film illustrates the constructional features of RCC columns, slabs, and beams in buildings. Columns are structural elements used primarily to support loads from beams and slabs and transfer to foundations. Vertical members of multi-story buildings are column members subjected to compressive loads from floors and beams. These are critical structural elements, failure of which endangers the whole structure. Reinforced concrete columns are usually square, rectangular, circular, or L-shaped in cross-section. Such columns are reinforced with longitudinal and transverse steel. Longitudinal steel contributes to load carrying capacity of the section, and transverse steel provides lateral support to the longitudinal steel and confines the concrete. Depending upon the type of transverse steel and composition of cross-section, columns are classified as tied column, spiral column, composite column, and pipe column. In tied columns, lateral bracing is provided at closed intervals in the form of closed loops known as ties. Spiral columns have the bars and the core concrete wrapped with a closely spaced helix. Composite columns consist of structural steel or cast iron column encased in concrete reinforced with both longitudinal and transverse reinforcement. Pipe columns are normally of circular, rectangular, or square hollow sections filled with concrete without any additional reinforcement. Construction of column starts from the foundation. The first step in the construction of tied columns is the cutting of steel reinforcement as per structural details. The cut reinforcement is also bent suitably to form lateral ties. Columns are critical elements and loads of whole building is transferred to the foundation through columns. So there should be a rigid connection between column and its foundation. This is done either by extending the longitudinal bars of columns into the footing or by providing dowels. A typical detail of second case is shown where dowel bars are represented as starter bars. In columns where longitudinal bars are offset at a splice, the slope of inclined portion of the bar with the axis of the column shall not be more than 1 in 6. Where splices are provided, they should be staggered, that is, center to center distance between bars is not less than 1.3 times the lap length. First of all, a starter or a kicker of about 75 mm thick is filled using wooden pattern. This is done so that column shuttering can be fixed in proper position. The reinforcement for columns can also be simultaneously tied at proper location by proper lapping the longitudinal bars with dowels which are surrounded by lateral ties. Before fixing the column shuttering, it should be oiled so that concrete will not stick to the shuttering. The column shuttering is fixed and separated from reinforcement using cover blocks so as to provide suitable cover to the reinforcement. The vertical straightness of column shuttering is checked using the plumb bob. To obtain dense concrete at site, the ingredients are mixed in a drum mixer. The ingredients are measured preferably by weight but sometimes by volume in small works. The ingredients are fed to the mixer when drum is in inclined position facing the hopper. After mixing for about 1.5 to 2 minutes, the concrete is discharged by tilting the drum on the opposite side. For columns, the depth of concrete to be filled in a single lift should not exceed 1 meter for ensuring full compaction of concrete. The compaction of concrete is usually done by inserting the nozzle of the needle vibrator into the column concrete. The number of days after which shuttering is removed depends upon various conditions. Thus, it is removed as per the advice of engineer in charge. The curing of column is done either by directly spraying the water or wrapping canvas around the column and keeping it continuously wet. Slabs are most commonly used structural elements forming floors and roofs of buildings for supporting loads normal to its surface. Common type of slabs are slabs supported on two parallel sides carrying loads by bending in direction perpendicular to the supports, also known as one-way slabs. Slabs supported on all the four sides can also behave as one-way slabs provided ratio of longer span to shorter span is greater than 2. One-way slabs can also be continuous over number of supports and can be cast monolithic with beams and columns. Slabs supported on all the four sides are termed as two-way slabs if ratio of longer span to shorter span is less than 2 and can be continuous over number of supports. Slabs can also be directly supported on columns without beams. Such slabs are known as flat slabs. A flat slab may have recesses formed on the soffit so that soffit comprises of ribs in two directions. Such slabs are known as waffle slabs. Ordinary rectangular or square solid slabs are normally designed as one-way slabs or two-way slabs and steel is provided accordingly. Here we will be mainly dealing with the construction of one-way slab which is cast monolithic with the roof beams. The graphic shows typical one-way beam slab arrangement. Beams may be downturned from the roof slab or at certain locations. Hidden beams can be provided for architectural reasons. The first step in the construction of roof beams and slabs is the fixing of shuttering or formwork. Timber and steel are most commonly used materials for shuttering. To get a better finish, normally steel shuttering is used in the construction of multi-story buildings. To facilitate construction, slabs can have their formwork made into panels. A typical detail of formwork for interior beam slab combination is shown through the graphics. After shuttering is fixed, steel reinforcement is placed as per design. The shuttering is simultaneously oiled so that concrete will not stick to the steel forms. For one-way slabs, main steel is laid along the shorter spans and temperature steel is provided along the larger span. Near the interior supports, alternate bars are usually bent up and also additional bars are provided for negative moments. The steel should be provided as per structural details. The alternate bent up bars can now be clearly seen through the graphics at the end support where slab is simply supported. This is the steel for the downturned beams which will be cast monolithic with the roof slab. In beams, except near the supports, the tension steel is provided on the bottom face and compression steel or hanger bars on the top face. The case is reversed at the supports. The two are surrounded by the shear stirrups and can be seen clearly through cross section at mid-span. For hidden beams, the width is normally increased and depth is reduced so that it is not visible. Also suitable cover to the reinforcement is provided in RCC structural elements to prevent steel from corrosion. The beam reinforcement should be properly anchored with the column by embedding it into the column to a length equal to the development length. The formula LD is equal to 5 into sigma S over 4 tau BD can be used for the calculation of the development length. To form a rigid connection at beam column junction, the reinforcement of one should completely pass through the other, a typical detail of which is shown. After fixing the reinforcement, it is checked by engineer in charge and then concrete of specified grade, normally M15, is poured and spread. The mix is properly compacted using the needle vibrator. The surface is finally finished using trowel and other hand tools. The care should be taken that there should be no segregation and bleeding. The concrete gains early strength after 24 hours of drying under normal atmospheric conditions. The RCC building components are normally cured for about 10 to 15 days for achieving better strength. The shuttering is removed thereafter as per the advice of engineer in charge.